Question number 1. An object is projected upward with a velocity 100 meters per second from the ground. If the air resistance is neglected, it will strike the ground. We know that we are considering an object which is projected in upward direction. Is moving under the gravitational acceleration. It means there is an acceleration tending downward. Therefore, the speed of the object will be decreased 10 meters per second within 1 second. Therefore, this object will move upward and becomes rest after 10 seconds. Then moving time in upward direction 10 seconds. Again, it will be back to the ground level within 10 seconds. Then total time take to strike the ground 20 seconds. We can get the answer. 4 is the correct answer for question number 1. Then question number 2. Consider the following statements made about the motion of a particle. Part A. Velocity of a particle cannot be reversed without changing the direction of acceleration. Now it is incorrect. We know that if an object is moving in this direction, the motion is in the right hand direction. I will consider an acceleration in opposite direction. It means there is a deceleration. Then this object should be decelerate and it will become zero. It will be at rest at a t time. Velocity should be 0, v to 0. Then it will move in opposite direction without changing acceleration. Again, its velocity will be increased. Like this object. The acceleration is constant in downward direction. But its direction is changing. Therefore, statement A is incorrect. Then statement B. When a particle is projected vertically downward with a large initial velocity, its acceleration will exceed the acceleration due to gravity. No, acceleration is not depending on initial velocity. Therefore, second statement also incorrect. Then third statement, part C. When the acceleration of the particle is 0, it must necessarily be at rest. No. If the acceleration is 0, it should be at rest or it should be moving within a uniform velocity. Therefore, it also false. Then all A, B, C are false. Answer 5 is correct for the question number 2. Then question number 3. An object is dropped from a helicopter which is moving horizontal at a constant velocity 45 meters per second, 180 meters above the ground. Time taken for the object to reach the ground. We have to give the time taken to reach the ground. The helicopter is moving in horizontal direction. Therefore, the released object has a horizontal velocity. It is equal to the velocity of helicopter. But the initial downward velocity of the object is 0. Therefore, it is a motion under the gravity, like a released object in downward direction. This velocity is in horizontal direction. It is not dependent to the motion of downward direction. We know that when an object is released under the gravity, in first second it will move 5 meters. Within second it will move 15 meters. Then third second distance is 25 meters. For the fourth second 35 meters. Now the object is at the height of 180 meters when releasing. For the fifth second 45 meters. 5 plus 15, 25, 20, 20 plus 25, 45, 45 plus 35, 80, 80 plus 45, 125, then 55, 125 plus 55, 180. Now, time taken to reach the ground, 1 second, 2 seconds, 3 seconds, 4, 5, 6 seconds. In 6 seconds, answer is 4 for the question number 3. Then question number 4. The figure shows the velocity time graph for a particle which starts from rest and move along x direction according to the graph. I will draw the graph. We have to select from the given statement, correct statement from the given statement. They have given velocity time graph 0, t1, t2, t3. Statement A. The particle comes to rest only at time t equals t3. T equals t3. No, we know that when velocity is 0, this is velocity axis, velocity becomes 0 at this point and this point. Therefore, statement A is incorrect. It will be at rest when t equals 0, t equals t2 and t equals t3. Then statement B, the particle returns to its original position at the time t equals t3. So we know that area of the velocity time graph is depending displacement of the object. For this part, this area representing the motion in plus direction, the displacement for plus direction, and this area representing displacement for the minus direction. But now we can compare areas. This area is greater than to this one. Therefore, the displacement for the plus direction is greater than displacement for the minus direction. It means if the object is moving like this in the plus direction, it will move a short distance for the minus direction. Therefore, it will not returns to its original position. Therefore, statement B also incorrect. Then C, the particle accelerates only during the time interval 0 to t1. We know that velocity time graph, gradient of velocity time graph is representing acceleration. Therefore, for this part, So this part and this part. There is a plus gradient. Therefore, object is accelerating in this part and this part. Therefore, statement C also false. All A, B, C false when known. Answer should be false. All A, B, C false. We have to correct the answer 5. All A, B, C false. In question number 5, an object dropped from a height h bounces back from the floor to a height h over 2. Which of the following velocity time graphs best represent the motion of the object? It is a dropped object. Therefore, initial velocity should be 0. And moving under the gravitational acceleration, therefore acceleration is constant, therefore gradient of the graph should be constant. It is a plus gradient in downward direction. Now, this is the final velocity of the object. And we know that when rebounding, velocity should be opposite. It means velocity should be minus after the collision. Then after the collision with Earth, its velocity should be a minus value. And it is rebounding to a height h over 2. It means the rebound height is less than the dropped height. Therefore, rebound velocity should be less than velocity colliding with Earth. There is an energy loss. There is a kinetic energy loss. Therefore, final velocity after the collision should be a lesser value to the initial velocity of the collision. Collision with velocity of collision with Earth. And then when rebounding, again it is moving under the gravity. Therefore, acceleration is equal to this one. Then gradient of the part of the graph, this part of graph should be equal to gradient of the part of gradient of the graph for this part. It means this line should be parallel to this line. We are finding acceleration by gradient of velocity time graph. Gradient is depending with this angle, alpha angle. It is under the gravity. Gravitational acceleration is constant, therefore alpha should be same for both parts. Then we can get answer 1 for the question number 5. Then question number 6. A bird flying at a height of 40 meters with a speed of 10 meters per second drops a small fruit from its mouth. If free fall is assumed, the speed of the fruit just before reach the ground is. Now again, we can consider the vertical velocity of the object is 0. It is dropped. Horizontal velocity is 10 meters per second. It is equal to the velocity of bird. But we have to consider vertical motion. When considering vertical motion, it is under the gravity to find the final velocity. V squared equals u squared plus 2as. We have to find the final velocity. Initial velocity is 0, 0 squared 0, 2 into acceleration 10 into displacement 40. Then V is 2 into 10, 20, 20 into 40. There are 2 zeros, 2 into 4, 8. Root 800. We can write it 400 into 2 root. Root 400 is 20. Root 2 is 1.4. Then we have to multiply 0, 2 into 14, 28. 28, or we can get answer directly. 20 root 2, it is given in the, this is the vertical velocity. We have to consider horizontal velocity also. Now, the horizontal velocity of the object is 10, it is constant for the whole motion, and vertical velocity is 20 root 2. We have to find the resultant. We can use vector parallelogram theorem. If the resultant velocity is u, we can write u 10 squared plus 20 root 2 squared root. 10 squared 100. 20 root 2 squared is 800. This value. Square root. 100 plus 800, 900. 900 root is 30 meters per second. 30 meters per second. Then answer is 5 for the question number 6. Then question number 7. Figure shows 5 displacement time curves for 5 different objects. The object which has an acceleration in the direction of the motion is represented by displacement time graph. We know that gradient of the displacement time graph is representing acceleration. Representing velocity. Gradient of displacement time graph representing velocity. If there is an acceleration, velocity should be increasing. Velocity should be increased. Then gradient of the graph should be increased with time. Then the graph should be in this case. Then answer E for the graph E for the E is the correct graph. Then answer is 5 for the question number 7. Gradient of displacement time graph should be increased with time because of the velocity should be increased for the accelerated object. Then question number 8. Figure shows velocity time curve of 3 particles A, B and C moving along a straight line. If at t equals 0, all the particles can be found together at a certain point on the straight line. Then at t equals 10. T equals 10. We have to consider given 5 statements. We know that if 2 particles can be found together, then displacement for the particles should be same. Displacement of the graph, displacement of the particles is represented by the area of the graph. Now we have to compare area. At t equals 10, area of graph A is 5 into 10, length into breadth, 5 into 10, 50. Then area for the graph A is 50. Therefore, displacement for the graph A, displacement for the object representing graph A is 50 meters. Then we can consider B. Area is half into base into perpendicular height. We have to consider this triangle. Base 10, perpendicular height 10. 50 meters. Then for the graph C, it is a trapezium. We have to find the area of trapezium. Half into sum of parallel sides 10 plus 5, 15, perpendicular distance 10, 75 meters. Now we can compare distance of objects 50, 50. There are same values for A and B. Therefore, particles A and B meet again. Answer 1 is correct for the question number 8. Question number 9. Which of the following curves correctly represent the corresponding velocity time graph for the displacement time graph in the figure? I will draw both graphs with the same axis. Displacement time. Displacement time graph is like this. We have to draw the corresponding velocity time graph. We know that velocity is represented by the gradient of the displacement time graph. For this part, gradient is a plus constant value. Therefore, gradient of the graph is a plus constant value. Therefore, velocity should be a plus constant for the first part. We know that when considering this angle, if it is, it means that angle between x-axis and graph. It is an acute angle. Therefore, gradient should be a plus constant, plus value. Then for this part, there is a minus gradient. The angle between graph and plus direction of x-axis is an obtuse angle. Therefore, there is a minus constant gradient. Constant means it is a straight line, therefore angle is not changing in time for this part. Then minus constant. I will compare magnitudes after getting the rough sketch. Then for this part, gradient is 0. If a graph is parallel to x-axis, gradient is 0. Therefore, velocity should be 0 for this part. Velocity 0. Again, for this part, the angle between graph and plus direction of x-axis is an acute angle. Therefore, there is a plus constant velocity. Now we have to compare magnitudes of velocity. Magnitudes of velocities for parts in the graph. We can identify this angle is greater than this angle. Therefore, velocity of the graph, this angle is same as this angle. These two angles are equal. Therefore, this velocity value should be equal to this velocity value. If you can't compare, you can calculate gradient by using units in the graph. They have marked units like this. There are 2 units in upward direction. There is 1 unit in downward direction. Therefore, we can calculate gradient. There is the same gradient but we can compare without calculating. Same gradient. And for the final part, this part, we can identify the angle. This angle is the angle less than to these two angles. We can identify clearly this graph, the gradient of this graph is greater than this graph. It means this angle is gap is higher value to this angle. Therefore, its final velocity should be a lesser value to this value. Then we can get the answer. Safety is represented by fourth answer. But don't think about values in x-axis. We have to consider only shape. There is a problem with values in x-axis, but we have to get, we can get only answer 4 for the question number 9. Question number 10. Which of the following graphs best represent the variation of velocity v with the time of an object being brought to rest by a constant resultant force? There is a constant resultant force. We know that according to F equals ma, according to Newton's second law, F equals ma, force directly proportional to acceleration. Force directly proportional to acceleration. But in the question they have given object being brought to rest, therefore final velocity should be 0. Then we can reject first, third and fifth answers. Sorry, first, we can reject third answer. Its velocity is increasing. Sorry, fifth answer, its velocity is increasing. Therefore 5 could not be the answer. We have to select answers from 1, 2, 3, 4. When considering this relationship, force directly proportional to acceleration. Therefore, we know that gradient of velocity time graph is representing acceleration. Therefore, gradient should be constant because of there is a constant resultant force. Gradient should be constant, therefore we should get a straight line. The graph should be a straight line graph and final velocity should be 0. By considering that 2 points, we can get the answer. 3 is correct answer for the question number 10.